In this video, we're going to take a look at Chapter 5 on gases, problem number 22. The problem reads, a sample of air occupies 3.8 liters when the pressure is 1.2 atm. For part A, what volume does it occupy at 6.6 atm? For part B, what pressure is required in order to compress it to 0.075 liters? Note that the temperature is kept constant. So once again, in this problem, first things first, let's make our chart. Alright, and so let's see. We're going to start off with, part 1 and 2. Alright, so let's take a look. First, we're going to go through and we're going to find what is the pressure, what is the volume. Alright, so at stage 1, let's see. Pressure at 1 is, let's take a look at the problem. Sample of air occupies 3.8 liters. Pressure is 1.2 atm. Alright? So we write 1.2 atm. Note that the units is atm. That's perfect. Alright? Then what is V1? Let's take a look. What is V1? Occupies 3.8 liters. Alright? Good. Alright, and let's see. Temperature is kept constant. This is a sign that we're going to use Boyle's law, because Boyle's law is a relationship between pressure and volume when the temperature is constant. So that should be screaming to you Boyle's law, alright? So we don't need to write like T1 and T1 because it stays the same. Alright, now let's look at stage 2. Alright, so in stage 2 we'll have P2 and V2. Alright, let's take a look. So, in stage 2, and now this is where we're going to do stage 2. Stage 2 is referring to part A. Okay? So let's call this stage 2 for part A. Okay? Just to keep things clear. So in stage 2 for part A, what is the next pressure? Well, stage 2 part A is what volume does it occupy at 6.6 atm? So that 6.6 atm is our P2, and then V2 is our question mark. Alright? So we're just doing part A. So we do Boyle's law. And Boyle's law states that the product of pressure and volume is constant, like this for an ideal gas when temperature is constant as well. P1 V1 equals P2 V2. And now we're just going to do substitution. So P1 is 1.2 atm. V1 is 3.8 equals P2 is 6.6 and V2, which is our variable we're solving for. So we divide by 6.6 and let's see, V2 ends up equaling 0.69, and then our unit, because we were using liters, and when you want to use liters whenever we're working with these ideal gases and stuff. So 0.69 and liters are a unit. Now note, this is for part A. This is our answer for part A only. Okay? Now let's take a look. Part B. What pressure is required in order to compress it to 0.075 liters? Now note, this is where, be careful here. This is a separate problem. It would have been easier for them to break it up into two problems, but they squished them together in the same room. Okay? So we're now on part B. This is a whole different, this doesn't apply. That 6.6 doesn't matter anymore. So we go and let's erase it. Oh, I can't erase it. Okay? Let's just do 2B. Okay? So this, don't worry about that anymore. That's done. That helped us with part A. We're on part B now. Okay? So we still have the same initial pressure and initial volume. That doesn't change. But now, instead of having P2 go to 6.6 like it did over here, we have, let's see, we have a different P2 and a different, a different P2 and a different V2. Whole different problem now. Let's see, so what pressure is required in order to compress it to 0.075 liters? So we go, okay, volume 2 is 0.075 liters, and for P2, that's our question mark. Okay? So once again, we're going to use Boyle's law where P1 V1 equals P2 V2. So we'll write that, and this is where it's going to be tough to fit this in, but let's see. So P1 V1 equals P2 V2. We know P1 is 1.2, V2 is 3.8. We know that P2 is our question mark or variable, and V2 is 0.075. All right? We do the division by 0.075 on both sides, and we come out that P2 is 60.8 ATM. Now you look at that and that's like, oh, and that's for part B. You look at that and like, that's a high pressure. Well, let's think about this logically in our heads, okay? With like, all right? We have something that 1.2 ATM, that's our initial, has a volume of 3.8 liters, okay? So think of 3.8 liters, like think of your soda bottles, that's a good amount of space. Now imagine compressing that, just squeezing that in all the way to only about 0.075 liters. So you took like this huge space here. Where can I draw it? Like right here. Think of this huge thing, and you have like little gas in here, and we squeeze that into a teeny tiny little space, and they're all crammed in there. That means the pressure now is really, really high, which explains this 60.8 ATM. 60.8 ATM. Remember, units is atmospheres because we're always working with atmospheres when we're doing the ideal gas law, or in this case, Boyle's law, which works with ideal gases. All right? Well, that's how we do problem 5.22. In recap, we once again made our charts of 1 and 2. We recognized that this was two separate problems. We had problem A, problem B. We worked with them separately. We did exactly what we did here using Boyle's law, P1, P2. We solved for V2. And then when we moved on to part B, we crossed off part A because that doesn't matter to us anymore. The initial information stayed the same, and then we solved for P2. We used Boyle's law again, and then came out with 60.8, and of course, remember your units, ATM. Great work. Dang it, I just checked the answer in the back of the book and realized that I'd made one mistake. I should have checked it before I did the video. When we look at this, let's look at sig figs. Oh the worst. Sig figs. We have two sig figs, two sig figs, two sig figs here. Look at this, even the veteran can make a mistake. We use two sig figs now, only 61 ATM. My mistake, you can sue me now. I'm kidding. Alright, there you go.